When we started to look at our statistics, we mentioned in the very beginning, if you can remember back, that using the word average in mathematics is really using a word that is in the plural, because the word average stands for the measure of center, okay? And in fact, there are three measures of center that we can use in statistics in order to see, first of all, how the data is, I suppose, spread, and secondly then how the data is gathered around a central value. Okay, so this kind of goes back to the normal curve where we said if you have a normal distribution, you have the mean, the mode and the median in the middle. I'm going to try and explain what they are in more detail in this particular section. So we're going to try and cover two sections in this lesson. First of all, we're going to try and have a look at the averages, the mean, the mode and the median, and then we're going to take a look at the actual measure of spread itself, and we're going to talk about the range and the interquartile range and so on. Okay, so let's go into averages. First of all, you'll notice averages, that there is more than one. Average is I suppose, describing a number of ways to measure the center. And it's m cubed. It's the mean, the mode, and the median. So you keep the three m's together. Now, what are they? What are these three m's? The mean, the mode, and the median. And I suppose the best way to calculate, or the best way to explain them is, the mean is the calculated middle. Okay, it's always going to be a mathematical operation. The median is the physical center. It's where you actually locate the slap bang on center in the middle of a range of numbers. However, there's a caveat. It's the middle of a range of numbers that have been already arranged in order of increasing value. So that's the key thing about the median. It's not just the middle value in any old array of numbers. It's the middle value, the physical middle of an array of numbers that have been ordered incrementally. Okay, increasing in value. And then the final one is the mode, and the mode is perhaps the number or the numbers or the item, indeed, depending what your data is made of, that appears most frequently. Okay, so therefore there's only one of them that can actually appear more than once. There can be more than one mode, and hopefully we'll demonstrate that as we go down through the questions. So, as we said already, there are many types of averages, and we're going to look at three. We're going to look at the mean, the mode, and the median. The arithmetic mean, which is always calculated, okay? And how is it calculated? Well, that depends. Is it just given as a list, or is it given as a frequency table? Okay, now if it's given as a list of numbers, you know what to do from primary school. You add up the numbers and you divide by how many numbers there are. So for example, if somebody said to you, what's the average age, what's the mean age of all the people in your class? Well, you'd add up the ages of everybody present, and if there were 25 students in your class, you would divide the total by 25. That's what that formula there means. Okay, if you have a frequency table given, it changes slightly, because if there's a frequency, then the arithmetic mean, the calculated middle, is the sum of the frequency times x over the sum of the frequencies. Okay, now we'll again see that as we move on. So that's two things to remember in terms of the arithmetic mean. It can be the calculated middle of a list of numbers, where we add them all up and divide by how many numbers there are, or it can be the calculated middle of a frequency table. That means then that you have to multiply the frequency by the value, add up those products, and then divide by the sum of all the frequencies that run on the bottom of that particular table. And again, hopefully we'll see that as we run through a couple of examples here. The mode is simply the term or the terms that occur most frequently. Now I want to bring you back to three words we had in earlier slides. You have what's called unimodal, you have bimodal, and you have multimodal. Okay, now what does that mean? If there is one particular term that seems to repeat itself most frequently, then it's unimodal data. If there are two terms that are repeating themselves most frequently, it is bimodal data. And lastly then, if there are a number of terms that are repeating themselves quite frequently, more so than any of the other terms of your data, then it is a multimodal set of data. And lastly then, the median is the physical center. Okay, it's the middle data value in a list of values that have been arranged in increasing order. Now again, I want to talk about the middle data value. When I talk about the middle data value, you actually might have to calculate the middle data value, because say for example that the middle falls in between two values. If the physical center is in between two values, then we have to take those two values, add them together and get their mean. Okay, now when does that happen? Well, the median will have a definite value that you can land on if the number of objects in your data set is odd. Okay, so take for example, if you have 35 pieces of data, the 18th piece of data will be the physical center, because that puts 17 to the left, 17 pieces to the right, 17 and 17 is 34, and the 18th value is 35. Okay, whereas if you had 34 pieces of data, well then that would give you the middle lying between the 17th and 18th data points, which means you'd have to add up whatever value is in the 17th and 18th position, divide by 2, and that would give you the physical center. So one thing I want to talk about the median is that the median may actually give you a result that is not part of your original data set. So if your data set, for example, has 34 values, and all of those 34 values happen to be whole numbers, well then obviously the median could come out as a fraction, a calculated fraction. And that means then that the median is a value that was not represented in the original data set, or doesn't really represent any number in the original data set. Okay. However, it's a valid center. It's just the only one that doesn't match any of the data values that are present in the set that you're working with. The mean could exactly be the same. The mean could give you a measure of center, again, that wasn't part of the data set originally. But the mode will always reflect the data set, because the mode is simply the term or the terms that appear more frequently. I hope that makes sense. The range then is the way in which we measure the spread. So if we're dealing with the mode, the mean and the median, we're measuring center. All right. If we're talking with the range, we're measuring the spread of data. How is it gathered around that particular mean? Should it be in a normal distribution? Or how is your data spread out? Okay, what's the lowest value? What's the highest value? And the range in particular is nothing more than the difference between the lowest value in your data set and the highest value in your data set. That's it. So basically what you're saying in relation to range is, what are we working with? What's the lowest value? What's the highest value? And what's the difference, the numerical difference between them? So range is always subtraction. Median is the physical center, where you may actually hit on a value if the original number of data pieces is odd. Okay, if it's even, you're going to have two values and get their average. The mode is the term or terms that occur most frequently, and the mean itself is the calculated middle. Okay, so let's take an example. It's probably the easiest way to do this. The ages of the 7 dwarfs are as follows. Happy, Doc, Sleepy, Sneezy, Dopey, Grumpy and Bashful have ages of 685, 702, 498, 539, 402, 685 and 619. Find the mean age. Now first of all, this is just a list of numbers. Okay, this is a list of ages. So there, all you've got to do in terms of that is, obviously you're going to be dividing by 7, but you've got to add up the total number of years that are there between the 7. So you've got 685, plus you've got your 702, plus you've got your 498, plus your 539, plus your 402, plus your 685, plus your 619, which gives you a total of 4,130. And then you divide that by 7, so you're going to equalize the ages, so to speak, but keeping the total number of years between them the same. That will give you, when you divide it by 7, 590. So the mean comes out as 590, but notice, nobody actually has that age. So the mean can be a value that is not part of the original data set, okay? But it's a calculated middle. That's most important. It's a calculated middle. That makes sense. Okay, the modal age. Now, is there any age that repeats itself? Well, let's have a look. 685 is there twice. Maybe Happy and Grumpy are twins. Now, obviously, they're not going to be identical. They'd be fraternal twins, because one is extremely happy, the other one's extremely grumpy. So obviously they don't share the same data set in terms of being identical. So 685, 685, that repeats itself twice. Nothing else repeats itself. So therefore, this is most definitely unimodal data with a mode equal to 685. Find the median age. Well, what's the physical middle? Now here's the caveat, and you've got to remember this. For the median, you can only work with data that has been arranged in increasing value. So who's the youngest? Dopey is 402. Who's next? Sleepy is 498. Then we have, who's after that? 539 Sneezy. Then after that, we have 619. And then we have the 685 twice. And finally, then we have the 702. 1, 2, 3, 4, 5, 6, 7. So there's the 7 boys. Okay. Now, where's the physical middle? You can do this actually quite simply. Watch. Just knock off one term from each. Ah, there's the physical middle. 619. Now remember what I told you. If the amount of objects in your data set is odd, then it will have an actual physical middle. There will be a number that will be at the middle. If it's even, unfortunately, then there'll be 2 numbers in the middle and you've got to take their average. But in this case here, the median age is 619. State the range of ages for the 7 dwarfs. Now, who's the youngest? The youngest is 402. The oldest is 702, which means the range is 300. It's simply how many units between the smallest data value and the largest data value. That's the range. Okay, when Snow White is included in the list, the mean age is 518.5 years. Find her age. Now, let me just take off what's there. So now we're going to include Snow White in all of this, okay? But here's what we do know. Snow White, W-H-I-T-E, has an age of X. We don't know what age she is. But when we take in the 8 ages this time, the mean is 518. So what does that mean? That means that, again, if I add those boys up, so multiplied by 7, which is 4130. So now, add the 7 lads together. That's 4130. Now add in Snow White, who's X. Divide that by 8 people altogether, and your answer should come out as 518.5 years. Okay? So that's the way in which we get an unknown data value from a set of data whose average is known. So again, 4130, that's the 7 boys' ages added up together. You now add in Snow White, so there are 8 people, so it becomes 4130 plus the unknown age, divided by the total number of people present, and we're told what the average is. So the first thing I would do here is I would clear my fractions. So 518.5 multiplied by 8, because I'm going to multiply both sides by 8 to clear the fraction, comes out as the following. 4130 plus X is equal to 4148. So that means X is going to be the difference between these two, and 4130 take away from 4148 leaves you with 18 years. Okay, done. Lastly then, now state the age range of Snow White and the 7 dwarfs. Well, the age range of Snow White, she's 18, so she's by far the youngest. The oldest, as we said already, is 702. So therefore, the range of ages between 702 and 18 is 684. So the range is always going to be an exercise in subtraction. Okay, so what about these 3? What about the mean, the mode, and the median? Which one is the best? Well, the answer is it depends on the data that you're using. Okay, are there pros and cons to all 3? Yes. Do I have to know them for the exam? Yes. You've got to know when to use them. And then you've got to know what the advantage of using them are and the disadvantages are. I'm not going to go through this with you. You can read this yourself, okay? The only thing I will tell you is this, that the mean and the median are the only 2 whose answers may be a value that was never in the original data set. Just keep that in mind, and you'll see that down there in the disadvantages anyway, okay? But you can have a read of that table yourself. It's very simple to understand. You do have to know when to use each one of each type. You could be asked, what's the best measure of centre to use in this particular question? Know what the advantages of each one are, know what the disadvantages are, and make sure you carry them in your head into the exam with you. Okay, so let's take page 115, question 2 as another example. The stem and leaf plot shown below records the weights in grams of a sample of plums. How many plums were in the sample? Now that just means you count them up, okay? So you just take a look, and don't forget the leaves represent each individual plum. The stem is the multiple of 10. Then the units that are arranged incrementally on the others on the right hand side of that particular bar, they are the individual leaves, they're the individual plums. So that'd be 26 grams, 31 grams, 33 grams, 34 grams, etc. So if I add these up, I should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 35 plums. Okay, so there are 35. Calculate the mean plum weight. Now what we have to do here, again, this is a list. So all I have to do here is add the different weights. So you add 26 to 31 to 33 to 34 to 36 to 36 to 38, 38, etc. Okay, so you add all the weights together, you get the total, and you divide that by 35. Now I'm not going to do that because I have it done. It's going to appear underneath here in a moment. So first of all, there are 35 plums. When I add up the masses and divide by 35, I get an answer that the total mass is 1,557. There are 35 plums, so the average is 44.49. And what average am I talking about? In this case, I'm talking about the mean plum weight. Now, part 3, calculate the median. And I would think it's probably best to do this, particularly if you're given a stem and leaf diagram. If you want to get the median, that means you want to get the middle. Okay, so what about doing this? Knock off them, then 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4, and then 1 and 1. Ah, look, what's left on its own? 45. So 45 is slap bang in the middle. And again, there are 35 plums, which means if there's an odd amount of data, your median will be an actual value. It'll be the middle value, which in this case here happens to be the 18th value, because 18 leaves 17 on the left hand side, 17 values on the right hand side, 17, 17 is 34, and 1 is 35. Yeah, so that's what did we say this? So that's 45. Okay, so that's one way of getting the median. Just knock them off individually and close in on the middle. Might be the best way to do it. What do you notice about your answers to 2 and to 3? Let me put the answer to 3 up there. So the median is the physical center, which is the 18th value. So the median is 45. Now take a look at the mean plum weight, 44.49. Take a look at the median plum weight, 45. They're close, okay? So they kind of agree. It's in and around 44.5 to 45. Now they're not the same, so the first thing I notice is that they don't fully agree, but they are close enough to each other, all right? There's a slight difference between them, but they do agree that the middle is somewhere in between 44.5 and 45. Now, part 5, describe the shape of the distribution. I told you what to do with the stem and leaf diagram before. You turn the diagram onto its stem, okay? So you put the stem down at the bottom. And that means then that I get a curve like this, see? Like that. And you can see straight away that that's a normal distribution, which I would expect. And why would I expect? Because we're dealing with plums. We're dealing with nature. We're dealing with natural distributions which are normally distributed, okay? So I would expect to get a normal curve. And lastly then, does the distribution have a unique mode? Now, let me clear all this stuff off here. Does it have a unique mode? Well, first of all, the mode is the object or objects that appear most frequently. You'll notice that 44 occurs 4 times, but you'll also notice that 47 occurs 4 times. Nothing else occurs 4 times. 42 is 3 times, 45 is 3 times. But there are 2 numbers that repeat quite frequently. 44 repeats itself 4 times, 47 repeats itself 4 times. So this is what we would call bimodal data. Now, if it's bimodal, what are the 2 modes? 44 and 47. Okay? So does it have a unique mode? No. It's bimodal data with a mode at 44 and a mode at 47. Okay. Page 118, question 9. The heights of random sample of 1,000 women are given in the frequency distribution below. Now this is a frequency table, okay? First of all, the mean is calculated slightly differently, and I gave you the figure or the formula already. It's frequency times the value over the sum of the frequencies. That's how you get the average in this situation. And by the way, that symbol mu, that's always a symbol for the mean, okay? Always the symbol for the mean. So in this case, they give us a table of 140 to 145. So look at the way in which they put these into what did we say it was called? A frequency distribution table, okay? Frequency distribution, how the frequencies are distributed throughout a given set of ages. So they pull the ages into categories more so than listing them individually. So you've got 9 females between the height of 140 to 145. You've got 65 between these 2 values, 177 between these 2 values, and so on. Okay. Now take a look at the value ranges themselves. 5, 5, 5, 5, 5, 5, 5, and 5. Okay, so there's a gap of 5 between each one. Now, sometimes with a bar chart, you have equal widths of different heights. With a histogram, you may have different widths with different heights. But in this case here, I think we're lucky enough to realize that all of the columns are going to be 5 units in width. Okay, and it does explain a note underneath each one. Note, 140 to 145 means that 140 is included, but 145 is not included. The 145s then will be in the next category. Okay, so estimate the mean height. So what I've got to do here is I have to multiply the frequency by the height. But there's a problem. How do I multiply 9 by a group? I can't multiply a number by a group of heights. So what I do here is I bring in what is called my mid-interval value. Now you may have done this already for your junior cert. The mid-interval value is simply the value that sits between these two. Okay, right bang in the middle. So 140 and 145. In the middle of that is going to be 142.5. So let's put that up there. 142.5. Now, between 145 and 150, in the middle of that is 147.5. Then we have 152.5, then we have 157.5, then we've got 162.5, 167.5, 172.5, and 177.5. And they're what we call the MIVs, the mid-interval value. Mid-interval value. And the reason why I need that is because I cannot multiply the frequency by a group. So therefore I allow the mean of that group to represent everything in the group. So I add the two numbers to get divided by 2, and that's going to represent that particular group. So what I have to do here now is I have to multiply the frequency by the mid-interval values for each box. So just allow me to do that very quickly. So 142.5 multiplied by 9, and that gives me, I'm going to write the numbers underneath, 1282.5. Okay. 65 multiplied by 147.5, and that comes out as 9,587.5. Okay, 177 multiplied by 152.5, and that gives me 26,000. Now we're going to get quite smaller numbers. It's 26,992. I have to make my numbers very small. 0.5. Okay, 325 multiplied by 157.5, and that comes out as 51,187.5. 253 multiplied by 167.5, and again now you'll notice they'll start to come down the other side because it should be a normal distribution, so the numbers then should get smaller. That comes out as 42, so we're seeing a little small bit of a drop, 42,377.5. Then we've got 133 multiplied by 167.5, which is 22,277.5. Then we've got 31 multiplied by 172.5, which comes out as 5347.5. I'm just going to remove that because that looks like a 9. I'm going to confuse myself later on, so let's just get rid of that for a sec. Okay, let's put that down again. So we've got 5347.5, and lastly 7 times 177.5, which comes out as 1242.5. So do you notice, again, can you hear the normal curve in there? It starts off at 1,282.5, it rises up to 51,187.5 and drops back down to 1,242. So there is a bit of a, you can actually see the normal curve in here. So estimate the mean height. So now what I've got to do is I've got to add all those together. So let's just bear with me for this. 1282.5 plus 9587.5 plus 26,992.5 plus 51,187.5 plus 42,377.5 plus 22277.5 plus 5347.5 plus the last one 1242.5, and that gives me a total on the top of 160295. So in other words, all of that, the sum of the frequencies multiplied by the mid-interval value, so 9 times the mid-interval value is 65, that's them all down here. Add them all together, you get 160,295. And now you've got to add up all the frequencies. So 9 plus 65 plus 177 plus 325 plus 253 plus 133 plus 31 plus 7, and that comes out as 1000. So when you multiply that by 1000, or sorry, when you multiply by 1000, when you divide it by 1000, you end up getting 160.295, and that's in centimeters. So that is what we call the mean height. Okay, that's the mean, and the mean, as we said to you already, is the calculated middle. Okay, so there's your mean height. So if this is a normal curve, just think, for example, if this was represented by something like that, which it is, well, then we know that 160.295 would be slap bang there. Okay, would be slap bang in the middle of its normal distribution. Okay, then it says construct a histogram to represent the data. Well, I'm just going to write the mean in here, 160 point, actually, I'm going to do 160.295. I'm just going to clear all that. 160.295 centimeters. Let's keep that there. Okay, construct a histogram to represent the data. Now, difficult for me to do on screen, but I'm going to use some graph paper, and I'm going to try and distribute this heights, or these heights, into bars of equal width but of different height. So first of all, 140 to 145, there's the first bar. Then we have 145, 150, which is the second bar there. Then 155, 160, 65, 70. So these are nicely placed, actually. And what are we up as far as 180, isn't it? Okay, so what's the first one? Has a height of 9. Now notice each box up this way is 10 units. Okay, so 9 is actually going to be way down here. I'm going to try and do this without waking up the machine to do something wrong. So it's going to be there, very, very small. Now that's way off. It should be under that, but I can't, because you can see what happens. You get these little buttons and I can't actually go to 9. 65 is the next one. So 65 will be to there. So that's 65. It's a little bit easier to do now. Okay, so there's 65. Then we have 177. So 150, 60, 77 is about here. So again, like that. And this will begin to tell a story too in terms of what type of curve we're going to get. 325. Well, 310, 25 is there. That's quite a large bar. And excuse my diagram now. I'm doing this without any rulers or anything else. That's dreadful, but you get the idea. That's 325. 253. So 253 is about here. So that's that way. And then we have 133. There's 100, 10, 20, 33. Which is about there. And then lastly, lastly, 31, which is 10, 20, 31, which is about there. And lastly then 7, which is way down here, like that. Okay. Now, describe, I knew they were going to ask this, describe the shape of the distribution. I told you what to do. Take the middle values, take the MIVs, like that. Then join them all together and see what you get. What do you get? You get a curve. Ah, no. Okay, go back. You get a curve. Apologies for that now, but that keeps coming up all the time. You get a curve that runs like this. There you go. Normal distribution. See that? That's just describe the shape. The shape is normally distributed. Okay, so that gives you an idea then as to how these things work in terms of the what we would call the grouped frequency. So it has a frequency, but it has a group. And whenever you have that, please remember to make sure that you use the mid-interval values of the group simply by adding the two values and dividing by 2 to get the value that's going to represent that particular group. All right, and then you multiply the frequency by each group and you get the mean by adding up the frequency times the value over the sum of the frequencies. Okay, so I'm going to leave you some questions to do now, page 116, 117, 118. They're all on what I've based on the mean, the mode, and the median. It's quite a straightforward exercise. There's very little difficulty in there. Just remember, first of all, which type is which measure of centre is one that's calculated, which one is the physical centre, which one is the repetitive centre, okay? And then when you're dealing with frequency tables, how to make sure you use the mid-interval value if they give you a group, or just add up a list of data and divide by how many objects there are, and so on. So I'm going to leave you those questions to do, but I'm going to carry on to the second section and leave you with a set of other questions to do along with this one, and that has got to do with the variability of spread. So I just want to go into this. So I'm going to leave you with the mean, mode, and median and those questions, along with this section and the questions that happen at the end of this, which is going to happen in 3 or 4 slides anyway, so not an awful lot left to do. So variability of spread, what does it mean? Well, say for example, if you walk into a butcher's, okay, and let's say for example that you want to take, say, the chicken fillets, and you weigh 20 individual chicken fillets. Now they're all not going to be the same, okay? There is one that's going to be the lightest, there is one that's going to be the heaviest. What we want to do is we want to see how the data is spread between the lowest weight and the highest weight, okay? Or if you go back to the Snow White and the Seven Dwarfs, she's 18, the oldest one was what, 702. So what's going on between that? How's the data spread out as we work with it? All right, and that's what we have here. So there are 3 things to remember. The range, which is nothing more than a subtraction exercise. It's the difference between the lowest value in a data set and the highest one. And then you have again the median. Now the median is the physical center, it's the physical half, okay? And then you have what we would call the upper quartile and the lower quartile. As their names suggest, they're quarters. Now keep in mind, if you go for the physical middle, you're breaking something in half. But half itself is the second quarter. So when we talk about the higher quarter and the lower quarter, we're talking about taking an object like this, and we're saying, okay, there's the lowest value, there's the highest value. Now, there's the physical center, which is called the median, and then we've got another value here, which is a half of the lower section, and another value here, which is a half of the higher section. Okay, so in a situation like that, you end up getting 1 quarter, 2 quarters, 3 quarters, and 4 quarters. Now, what I'm interested in particular is the median, which is the halfway value, but I'm also interested in the lower quartile here, which is a quarter the way up your set of data, and the higher quartile, which is 3 quarters the way up your data. And again, if I take the value of the lower quartile and the value of the higher quartile, the higher one minus the lower one is what we call the interquartile range. Okay, now I'm going to work with this with you in a couple of examples, but that's what we're dealing with. So we're dealing with the range, which is nothing more than the difference between the lowest data value and the highest one. We're dealing with the median, which is the halfway value or the second quarter on your way up any particular set of data. We're then going to talk about the lower quartile, which is the value that's a quarter way up, and the upper quartile, which is 3 quarters the way up. But there is again a little small calculation to keep in mind when we're doing these things, okay? And I'll demonstrate that as we move along. Okay, so let's just remove that. Now, the following sets of numbers have a mean of 4, but the spread is very different in each case. So I want you to take a look at these 3 sets, okay? They all have a mean of 4. So in other words, if you were to put the first set into your calculator and divide by 5, 4. If you were to put these numbers into your calculator and divide by 5, 4. Put these numbers into your calculator and divide by 5, 4. But you notice, the first have no spread. The first ones are all the same. It's a uniform distribution. There's no spread of data. The second one has a relatively small spread of data, between 1 and 8.3. So the range is quite small. But the second one runs from minus 196 all the way up to 174. The actual range is huge. Okay, so no range in the first one, small range in the second one, huge range in the third one. So the range is one way of very quickly trying to figure out what is the spread of data when you take in the data points that are given to you. We have 3 ways of measuring the spread of data in a set, or the variability of data in a set. One is the range. Told you about that already. It's the highest value minus the lowest value. That's it. That's all you've got to do. The interquartile range, which is the upper quartile minus the lower quartile value, okay? And then the standard deviation, which I'm not going to do in this class, I'm going to leave that to the next class on its own, because I really do want to speak about that, which is sigma, okay? And we'll speak about the standard deviation on its own after this particular section. So for today, all I'm going to look at is the range and the interquartile range. The range, nothing more than the difference between the lowest and smallest. The interquartile range, the difference. Anytime, by the way, you hear the word range, it's difference, okay? The interquartile range is the difference between the lower quartile, which is a quarter of the way up a set of data, and the higher quartile, which is 3/4 of the way up a set of data. Okay, so quartiles. Now, as the name suggests, when you hear about a quartile, it means a quarter, okay? And in anything, there are 4 quarters. There's the first quarter, there's the second quarter, which is the half, there's the third quarter, and there's the fourth quarter, which is the full thing. Okay, so the two we're interested in mathematically is the lower quarter, the first quarter, and the third quarter. The second quarter is the median. So in essence, we're going to be looking at the 3 of them. The lower quartile, the quarter way, the second quarter, and the third quarter. They are of extreme importance in terms of maths. The quarter value is referred to as the lower quartile, and the 3/4 value is referred to as the upper quartile. Okay, if any of the quarters of a total set of data points result in a whole number, then we have to take the mean of that data point in the next point. Now, what does all that mean? Well, again, say for example, if I get a quarter of 36, say there's 36 objects in my data set, okay? A quarter of that is 9, but you do not take the 9th value as being your lower quartile. If you do your division by 4 and the number comes out as a whole number, then you take that one, that data point, plus the one above it, and you get their mean, okay? If a quarter, when you divide by 4, if it gives you a decimal value, then you simply move to the next highest data point. You always round up in this case. Even if it's, say, 3.2, you still round up to the 4th value. So if the quarter gives you a fractional answer, then you round up to the next data point. And lastly, then, the difference between the upper and lower quartile is the interquartile range. So hopefully this might be able to demonstrate it to you here now. So here's a work example. First of all, this is an unordered stem and leaf diagram. The key is telling me that the numbers read from left to right represent days. So the number to the left of this particular bar is the stem. The numbers to the right of the bar are the leaves, and we read them as 5. This one here, 5, 3, 3, 1. This one here would be 16, that'll be 21, that'll be 27, that'll be 48, and so on. So I now know what I'm dealing with, okay? And they are days, simple as that. So in order for me to use this, the first thing I have to do is I have to order the stem and leaf diagram. Can't use an unordered stem and leaf diagram. It has to be ordered. So watch what happens when I order it. Ta-da! Ordered. The wonders of modern technology. Now, once it's ordered, I can calculate the median, I can calculate the lower quartile, and I can calculate the upper quartile. So just allow me to do that for you. So let's do the median first. Okay, the median is the halfway value. First of all, how many values are there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 28, 32, 4, 6. There are 36 values. What's a half of 36? 18. But I don't take the 18th value. I take the 18th and 19th together. So whenever your division ends up in a whole number, you have to take that plus the next one. So half of 36 is equal to 18. But if I was to take out the 18th value, what would it do? It would leave 17 values to one side and 18 values to the other. It's not the middle. So I have to take the 18th value and the 19th value in order to get their mean. So where is the 18th value? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 and 19. Aha. So what do they represent? They represent 12 and 13, which means the median is going to be 12 plus 13 divided by 2, which is 12.5. That's your median value. Okay, that's slap bang in the physical middle. Now, what's the lower quartile? The lower quartile is a quarter of 36, and a quarter of 36 is 9. Now again, we've got a bit of a problem. 9 is a whole number. So I have to take the 9th and 10th values and add them together. So what is the 9th and the 10th value? Let me just take that circle up there off. Okay. The 9th and the 10th value. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the 9th and the 10th, which represent 5 and 5 over 2, which is 5. Okay, so there's your lower quartile. What is your upper or your higher quartile? It's 3/4 of 36, which is 3, 4, 6, 9, 3, 7, 27th value. But again, because 3/4 of 36 gives me a whole number, I can't use that 27th point of data. I have to take the 27th and the 28th point of data. Now, where are they? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 24, 25, 26, 27, 28. Those two. So 27th and 28th value are 21, and 21 divided by 2, which is 21. So that's the upper quartile. Now, when you have the lower quartile as 5 and the upper quartile is 21, 21 minus 5 is going to be 16, which is the interquartile range. That's how it's done. Now, what would happen if the median had given me a fractional value? So let's say, for example, it was half of 35. Say there was 35 numbers here. A half of 35 would be 17.5. In that case, I would have to take the 18th value as being the middle. If a quarter of 35, let me just point this out to you. So a quarter of 35 is 8.75. So therefore you take the 9th value. And then the upper quartile would be 3/4 of that, which would be 26.25. So therefore I would take the 27th value. So it's easy to remember. If you're getting the median, you divide by 2. You take the number of data points that are in your set, divide them by 2. If you get a whole number, take it and the next one and get their mean. If you get a fraction, round up to the next highest data point. If the lower quartile, when you divide by 4, gives you a whole number, take that data point on the next one and get their mean. If it gives you a fraction, then go to the next highest data point, and the same thing with the upper quartile. Okay, so let's clear that and see what they were asking here. So, the data, as we said in this case here, is also positively skewed. It's inverse J-shape. Now, I've told you this before. Take the stem and bring the stem down onto the horizontal. Then what do you get? So, look, if the stem is brought down this way, we get something like this. Starting high and very quickly descending to low values. That's an inverse J-shape. So keep in mind, it's not negative, it's not positively skewed or negatively skewed. It starts high and it runs down low very, very quickly. So it's an inverse J-shaped distribution. Okay. The median is the middle value, but because there are 36 values, half 36 is 18. If the half gives you a whole number, so a half of 36 is 18, you take the 18th value and the 19th, which in this case here, I told you, were there, 12 and 13. So that means that your median is 12.5. Okay. The interquartile range is the third quarter minus the first quarter. But again, there are 36 values. Quarter of 36 is 9. So you take the 9th and 10th value, which is 5 and 5 divided by 2 gives you 5. 3/4, the way up of 36 is the 27th, is 27 I should say. So you take the 27th and 28th value, which is then going to give you 21 plus 27, which gives you 20. Right, now 27th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24, 25, 26, 27. So you want a 27 and 28. Sorry, that should be 21 and 21. It's 21 divided by 2, which is 21. I knew there was something wrong there. So it's 21, okay? And then the interquartile range is the difference between them. I've done this already. 21 minus 5 would be 16. Okay, apologies for that little typo there. I'll fix it in the slides and I'll re-upload them for you. Okay, so let's take this example, page 124, question 4. The following data indicates the electricity consumption in kilowatt hours for 20 typical 2-bedroom apartments in Dublin. Draw a stem and leaf diagram to illustrate the data. Now, first of all, what's my stem? Well, I'm running from a lowest value of 7 to the highest value of, I can see the highest value there is 16, isn't it? Yeah. So I'm running from 7 to 16. So therefore, I can take my stem as being multiples of 10. So my stem will contain 0 and 1. Okay, and again, thanks to modern technology, I can do this out for you like that, and I also have them in ordered leaves. So the 3 7s, the 8, the 4 9s, the 0, then the 5 1s, the 2, the 3 3s, the 4, and the 6. And again, the key, if there was a key to be drawn here, if there was a key to be drawn, which it should be, the key would be, say, 1 7 equals 17. And that has to be down every single time you do a stem and leaf diagram. Okay. Describe the shape of the distribution. Well, the shape of the distribution is going up this way. Okay. So it's very hard to describe it actually because it's going up. I suppose you could call it negatively skewed. If you take the 0 and 1 this way, what are we doing? We're going up like that. See? So I would say that is definitely negatively skewed. So you could call it a negatively skewed diagram if you wish. Okay. And then, next question. Find the range. Now the range is the difference between the lowest value. So the range is equal to the lowest value taken away from the highest value. The highest value is 16. The lowest value is 7. So therefore the range is 9. Find the median. Now the median is the halfway value. Again, you can do it this way if you wish. You can start, knock off the lowest, highest, then 1 like that. Just keep doing this if you wish, just to show you that it does work. Keep knocking these things off until you come to an agreement. Where are we? This one, this one, this one. Oh, there they are. Okay, so how many do I have in here? What is it? 20. Half of 20 is 10. So because half of 20 is 10, I cannot take the 10th value on its own. I've got to take the 10th and the 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th and the 11th value. So therefore the 10th and the 11th value are these two, just as well the same values. So that means that we've got 11 plus 11 over 2. So therefore the median is 11. All right. And the interquartile range. Now, let's just do this slowly. The interquartile range. I want first of all the upper quartile and I want the lower quartile, and when I get them, the difference between those is the interquartile range. That's how it works. So upper quartile, it's 1/4 of 20. Just think about that. And 1/4 of 20 is 5. But because the quarter comes out as a whole number, I have to take the 5th and 6th value. What are they? 1, 2, 3, 4, 5. The 5th and the 6th value is 9 and 9. So therefore, the upper quartile is 9. Okay? Sorry, that's the lower quartile. Oh dear, that's the lower quartile. Do that again. Upper quartile, lower quartile. So we're dealing with 1/4 and 3/4. No, I have it right. Okay, so 3/4 of 20 and 1/4 of 20. Let's do that again. 3/4 of 20 is 15. So I need the 15th and 16th value. And down here, I want the 5th and the 6th value. Okay, so let's take a look at that. The 15th, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these two here contain the upper quartile. That's 12 and 13. So it's 12 plus 13 over 2, which is 12.5. So that's the upper quartile. Now, 5th and 6th, 1, 2, 3, 4, 5, 6. These two. So that means it's 9. So therefore the interquartile range is 3.5. Okay, so that's the way the mean, that's the way the mean, the range, the median, and the interquartile range works. Simple exercise. The only thing you need to remember is this. If 1/4 of the total number of data points gives you a whole number, take that data point plus the next one and get their mean. If it gives you a fraction, then round up to the next data point. Okay, that's the easiest way to do it. Same for the lower quartile, the same for the upper quartile, and then subtract the lower quartile from the upper quartile to get the interquartile range. So that's where I'm going to finish. I'm going to ask you now as well to take page 123 to 125 with these questions, along with the previous questions that I set you on the mean, mode and median. And again, if you have any questions on these, come back to me. If not, you can hold them until the live class later this week, and we're going to go through them anyway at that stage.